Hi, this is Pat Long. Welcome to the fourth section of our video series. In this section we're going to be looking at generating outputs using ODS and other SAS procedures. So in this final section to the base SAS programming performance-based exam prep course, we're going to look at the generating reports and output. First off, we're going to look at generating a list of reports using the print procedure. We'll modify the default behavior of Proc Print by adding statements and options, including the var statement, the sum statement, the where statement, and we'll also use the ID statement and by statement. So let's jump into the code and look at these by example. So now we're going to be looking at generating summary reports and frequency tables using some SAS procedures. We're going to produce one-way and two-way frequency tables using Proc Freak. We're going to look at the some options including n levels and order equals. We're going to see how we can use Proc Freak to validate data in a given SAS dataset. We're going to calculate some summary statistics using Proc Means. We're also going to look at some options we can add to enhance summary tables. And we're going to look at identifying extreme values using the Proc Univariate. So let's jump into the code and look at these all by example. So let's start off by looking at a very basic example of Proc Print without using any of the special options. Let's look at SAS help.cars, and I'm just going to output the first 5 observations using the obs equal option. And okay, so this is just basically Proc Print data equals and the run statement. So here you see in the results tab what you'll get with no special options. Notice we have an obs column here, which gives the number of the observation or the row number. So yeah, now let's look at the different options that were outlined. So modify the default behavior of Proc Print by adding some statements, such as the var statement. Okay, so we'll use the var statement if we want to restrict to only see particular columns within the SAS help.cars dataset. Within the SAS help.cars dataset. So var statement, let's say we only want to see make, model, MSRP, and invoice. And so this is much more to the point if that we're only interested in MSRP, so you can see where the var statement might be useful within the print procedure. Again, I've just restricted it to the first 5 observations, so it's easy for us to look at. Now let's look at what the sum statement does. Let's say we're interested, well, there's only 2 numeric values, so let's say we're interested in the sum of the MSRP and the invoice, and this might be useful if, say, this is the data set of a car dealership's inventory. It might just be easy to have this in an output where you have the sum at the bottom, and so this will sum the contents of the MSRP and invoice columns. and you'll see this in the output. So yeah, here's what I mean. This might be useful information if in a much bigger data set. So you can see where the sum statement is useful within Proc Print. Okay, now let's look at selecting observations with a where statement. So similar to a where statement inside the data step that we've looked at in an earlier video. So I'm probably going to use more observations than this one, just to make it a little bit more, just make it a bit of a better example. So let's go type equals, so this sedan, let's go SUV, and I think that's how it's spelled in the data set. I'm not actually outputting the type equals column. Why don't we do that? Just so you can see that I'm only selecting type equals SUV. And we'll just leave the sum statement in there. Remember, we're looking at the where statement here. And I've selected the first 50 observations. So here you go. Okay, yeah, I spelled SUV correctly in terms of whether it was all uppercase. So yeah, and you actually get the observation number within the SAS help.cars data set, which is quite cool. And so you can see what's been excluded. All these observations 2 through 26 were excluded by the where statement. So yeah, you can see how that's quite useful. So now let's look at the ID statement. And I'll just copy and paste this example, and I'm just going to, I'll just do ID type. So you can see here we replaced the obs column with an ID of type, which shows us the type of each car. Probably wouldn't have the second column also be type if you're going to use the ID. I'm going to take that out so it makes more sense. So yeah, again, notice we don't have the obs number because we're replacing the ID of obs with type. So yeah, that's about how you use the ID statement. And now let's look at using the by statement to process groups. If we're going to use a by statement, we actually have to sort the data set. So I'm going to do a proc sort, which we're very familiar with from previous videos in the series. Sorry, it's SAS help .cars, and I'm going to make a work library data set of the same name. Let's do it by type. And so if I'm doing a proc sort by, then I'm going to have to use the same by variable in my Proc Print, which we'll see in a moment. Just run that, make sure I didn't have any errors. Okay, we don't need to look at the data set. And now let's just say by type, and let's take out type from here. Var make model MSRP and invoice. We can just leave the sums in there, that's fine. Say obs equal to 20. Oh, you know what? I need to use, we had an error because it was not sorted. So I'm using the work library one, and then we won't have that error. Okay, so here basically you see we have type equals hybrid, and a summary table there with the total MSRP at the three hybrids we have in our data set, and then type equals SUV, the total of the 17 SUVs we have in our data set. So I only selected the first 20, so we only have hybrid and SUV based on the sort. So yeah, that's about it for what we need to look at for the print procedure. In the next video, we'll be looking at Proc Freq, or the frequency procedure. Now we're going to be looking at generating reports and output. Further, we're going to look at enhancing report system user-defined formats, titles, footnotes, and SAS reporting options. So we're going to look at proc format and the value statement and the CNTLIN equals option. We're also going to use the label statement to define descriptive column headings within a data step, and we're going to control the use of column headings with label and split equals options in the print procedure. So let's jump into the code and look at all these by example. So now we're looking at generating summary reports and frequency tables using the frequency procedure. So now we're looking at generating summary reports and frequency tables using SAS procedures. First off, we're going to produce a one-way and two-way frequency table using Proc Freq. So let's start off with a basic example. Proc Freq data equals, and we're going to use the SAS help.class dataset. And we're going to use the table statement for tables H and O. So I didn't spell Proc Freq correctly. That's why the tables statement wasn't showing up in blue. And there's a run statement, and let's see what this looks like. So this is a one-way frequency table. So yeah, we just basically get the frequency by age, the percent, cumulative frequency, and cumulative percent. So it's kind of a useful little summary table. Now let's look at what a two-way frequency table looks like. I'm just going to copy this. And for this, there's a column called sex, that is the gender of the row and class. So let's look at this. This is the two-way frequency table. So you can see you get a bit more information here. So you have age on the row and sex on the column, and then a total. You also get the percent across the row and percent across the column in the output. So yeah, I mean, it's good for seeing various categories by gender and by age. So now let's look at some options with the frequency table. So let me just show you what n levels outputs. So it displays a number of variable levels. So it gives you a lot of summary information, probably more than you ever wanted. But let's look at what the output looks like. So yeah, basically gives you all the variable levels. You know, there's 19 different names, there's 2 different genders, there's 6 different ages, 17 different heights, 15 different weights. Then it just gives you summary tables for all of those variables. So that's a lot of information. So n levels is good if you're doing sort of exploratory data analysis, I guess. So let's look at the order equals option. Okay, so I'm just going to do the one-way table with age, and I'm going to put order equals frec. So what this does is basically orders the output based on the frequency. So the most common so the most frequent age comes first, and then the second, and then the last, whereas the default would be in the order the data set is in. So yeah, that's the order equals option. That's about all you need to know about that one. So looking at what you might want to do to use Proc Print to validate a data in a SAS data set, I'm going to have to do a bit more of an involved example here, just to get some data in there. So based on what the examples we've already looked at with the one-way tables, you can see that it's a good tool for detecting anything that's obviously an outlier or out of the ordinary when you're doing some exploratory data analysis or something of that nature. So here I'm just using some macro variables. I'm going to create a one-row data set of the same format as the SAS help.class, and then add that to a work library version of SAS help.class, and then I'm going to look at the frequency of age within the final data set. So bear with me for a second. Name equals, and this is a good review of what we looked at in section 3 using macro variables to enhance SAS programs. So here I'm saying weight equals ampersand weight, which is the macro variable I set up here. Name equals simget student name, which was the macro variable I set up there. age equals ampersand age. Sex equals simget sex, and height equals ampersand height. So I'm going to run the, well, before I run that, let me append it to SAS help.class, and we'll make a new data set called class updated set SAS help.class and new student. This is how we append one data set on top of another using the set statement. That was also covered in another video. And now let's do a proc freak of our new data set, which is called class updated. And so that was a lot of code I ran through. Hopefully I didn't make any typos. Let's run that, and we'll keep an eye on the log, make sure I didn't do anything egregious. Doesn't look like my new entry got in there. Oh, yep, I did have a typo. So let's fix that. It's good. If you see me troubleshooting my code, so I think I'm good now. Let's try this again. No errors in the log this time. And back to what the reason we did all that was to use Proc Freak to validate data in a SAS dataset. And so here we'd probably maybe see 16 as a bit of an outlier, but 35 will be way out of the range of what we'd expect to see. So I think we could say, you know, this is a good tool for just seeing an initial validation of whether a particular data entry is a little bit out of the ordinary. So let's move on to the next section after that overly extensive example. Let's look at calculating summary statistics using Proc means. I'm going to use a different data set here. Let me use SAS help.baseball. And we'll just look at the most sorry, I need to put data equals in there. We'll just look at the most basic example with no options used, and see what Proc means outputs to us. So again, this is SAS help.baseball. And basically for each numeric variable we get a nice little the number of observations, the mean, standard deviation, min and max. Note here, the n is 322, there's 322 rows, but for the salary, I just know from messing around with this toy data set a lot that there's a bunch of missing values for salary, and of course log salary is derived from salary, so it too has the same number of missing values. But yeah, again, you get the mean, the standard deviation, min and max. So let's look at you know, some options you might commonly use. In Proc mains. So yeah, let's look at so if I wanted to look at a class, let's go division team. Then these are all statements within the means procedure. Division by team. And let's look at a var statement, just like in the print procedure. I'm just going to look at home runs, which is n home. Yes, it's n home. And I'm actually going to restrict this using the where equals, just so we don't get too much output. Let's do where equals league equals, so this is just National League. There's the American League and the National League still in baseball, so here I'm just going to be looking at National League players. And yeah, so let's just look at what this output looks like, and then I'll show you, an option or two that you can use. Yeah, so here's so here you see this. We have the class classes of division and team. So you get some summary statistics on the home runs, and there's some nice labeling in this data set, so you don't have to rely on knowing what n home means. It explicitly tells you home runs in 1986. And again, I restricted this just to the National League, so it's just the East and West divisions, and then there's each team in those divisions. So let's look at what one option you could have would be to just put the mean. So this, that would get rid of the standard deviation and the min and max, and you have just a simple table. Doesn't have to be the mean. There's a lot of options you can look up. You can do the median, or you could output the median, the mean, and the standard deviation. And, you explicitly say that. If you don't, then it will output NOBS, mean, standard deviation, min, max. So yeah, those are some of the options you can use with proc means. I'll leave mean in there in the code. So now let's look at proc univariate, or the univariate procedure. Just going to give a basic example using the data set I created earlier called class updated, where I added my own value on top of SAS help.class. So proc univariate data equals class updated, and I'm interested in again, this var statement is in proc means, proc print, and proc univariate. I'm interested in var age, and let's run that. And yeah, you'll see how good proc univariate is for identifying extreme or missing values, because I did put an extreme value in, if we remember. So you get standard deviation, the mean. You also get the student's test statistic. And you get quantiles. You get the extreme observations. So yeah, obviously 35 kind of, whatever way you slice it, 35 stands out a lot. In the quantiles, because I think everything else is within one standard deviation of the mean and the median, whereas this seems like it's more than 3 standard deviations, or about 3 standard deviations away from the mean and the median. So Anyways, there's a lot of information in there. It's a bit of a silly example, but it will probably tip you off to that being an outlier. Okay, so that's about it. We covered the means procedure, univariate procedure. And in the next video, we're going to be looking at using Proc format to define custom formats. Yep, so. Now we're going to look at generating reports using ODS statements, or output delivery system statements. We're going to identify the output delivery system destinations. We're going to give basic examples of ODS HTML, ODS PDF, ODS RTF. We're also going to give a brief summary of what the style equals option is. And we're going to create files that can be used, viewed in Microsoft Excel. So in this video, we're looking at enhancing reports using user-defined formats. So let's get started with the format procedure. And we're going to be using the value statement in the first example. So I'm going to create I'm creating a so using Proc format, I'm going to create a catalog storing these values that I can use down the line as much as I want. I'm actually going to store this in my work library, so it's not permanently stored, but you can store them. You can store your formats in a permanent location. But for the scope of this exam, I'm just showing an example. So I'm going to use this this format in the sashelp.cars dataset, but you could use it. But the good thing about the Proc format is that you could then turn around and use this in another dataset that may be similar, rather than continually recreating a format within a dataset, within a data step. So let's just run this and make sure I haven't made any syntax errors, which I have. What did I do? Oh, yep, definitely need that. Okay, so that looks good. Okay, and now to actually use it. So again, I said I was going to use it using the sashelp.cars dataset. So let's go sashelp.cars. Let's just use the keep equals dataset option to only keep a few columns. I only want make model and MSRP. And I'm going to make a new column called price equals, and I'm using the put statement to take MSRP and format it using the format I just created up here using the value statement called prices. And notice how I format it in a way using the period like I would if I was making it a format of for, or as we looked at with the date formats in earlier videos. It's going to have a period after it. And I think that's it. And let's look at what we end up with here. So yeah, now I have a price column where it says mid price, high price, depending on the value and based on the format procedure I used up here. So you're probably thinking, why would you do why would you do that? But it comes in really useful if I've got 10 different data sets where this format could be used. I don't have to keep on rewriting it. And again, you can save these somewhere other than your work library, and you can just call on them whenever you need. So let's look at the CNT LIN equals option. And for this, I'm going to have to do a bit more of an extensive example. Actually going to create a data set called BB format. Meant to mean like baseball format. And I'm going to call the first column format name. And it's going to be character. And then I'm going to put a start, an end, and a label, which is also going to be character. And I'm going to use data line statements. Actually, I like to indent that. Data lines. And I'm going to call these HR group. Starting at 1, 10, and this group is going to be labeled low. I'm just going to make 3 groups, so this one's going to be 11 to 30, or 20, let's make it 29. 29, that's going to be called mid-range. And I'm going to call this logger. And this is just going to be 30 to 90. I don't think anyone's hit over 90 home runs yet. So they certainly didn't in 1986. So okay, so I made a data set there. Let me just make sure there's no error. And we'll get to where we're going to use the CNT LIN equals option. Oh, looks like I have an error in there. Oh, okay. No, sorry, it's a warning, and it assumes I wanted data lines, and it was misspelled, which it was. So SAS helped me out there. Let me just fix that. So it will be correct next time. But it ran as if I had put data lines in there. Just gave me a warning. So here I'm using the proc format CNT LIN equals option. So run. So creating a format using the data set I created up here. And then I can call on this now. Let's use the frequency procedure because we just looked at that. Data equals SAS help dot baseball. And I'm going to use the format that I've just created. And we're going to look at home runs, which is why I made these 3 distinct groups. So format n home and HR group. Okay. Okay, so here you see I use the CNT LIN equals this data set. And now I'm going to call on that format in my Proc Freak output. So let's see what that looks like. Assuming I haven't made any syntax errors. and I don't. So here you go. You get a nice view with the frequency procedure. Oh, I didn't account for 0. I probably should have put that in the low. But anyway, so it added an extra category because I didn't make that one. So there's 175 in the low category, 121, and you also in the mid-range category, and then 13 in the slugger. That's 30 or more home runs in the year, 4% of the players in the data set. So yeah, and remember the example was quite extensive, but we had to make this data set so we could show what you did with the CNT LIN equals option. Okay. So now let's just look at how you might use the label statement to define descriptive column headings. Let's go back to the SAS help.cars dataset, Proc Print data equals SAS help.cars. I'm just going to limit it to 10 observations so we don't get so much output. And I'm only going to select a few columns: make, model, and MSRP. I'll run this. Well, I'm not using the label statement just yet. And so, yeah, so that's the initial output. Now let's make a data set called cars in my work library from SAS help.cars. And I'm going to add a label to MSRP, which I'm going to call recommended retail price in USD. Yeah, that works. And run statement. Okay, and oh, sorry, I didn't put set statement in there. So yeah, let's look at what that looks like. If you remember, our old proc contents shows you what labels look like, among other things. So yeah, let's look at that. So we're running this data set where we use the label statement. So yeah, with the contents procedure, we get some stuff we may not be that interested in, but we also get this label column. You see some things already have labels, but here's the one I put in for recommended retail price in USD. And that was for MSRP. And you remember I did this. You could see what it looks like in the print procedure now, because I'm going to use mine. This is my work library cars data set. And oh, I have to use, if I'm going to use it in the Proc Print, we're going to get into this. In the next section, I have to use the label option. So let me just put this down here where it comes into play. So you have to explicitly use the label option. So here I put the label option. Now you'll see the recommended retail price is here. So it's a bit more of a meaningful label instead of just the column name MSRP. Maybe maybe a lot of people know what MSRP means anyway. So, but this is just an example. Let's look at what the split equals option can do. So there isn't really a good character to split with. Basically, the split equals option specifies a line break based on the character in the string of the label. So one thing I can do, although it's a bit silly, but you'll see it as an example, is I can split it based on this character here. The start of the parenthesis in our label for MSRP. So it should start a new, it should break for a new line at that character. So yeah, you see how it's done that. It's gone to a new line. And this example is not very useful. You probably wouldn't do that, but if there are examples where that might be useful, it's a good tool to have. So that's the split equals option. So okay, yeah, and I left a note in here to explain what it does. Okay, so that's about it for this section. Next, we're going to be looking at the generating reports using the output delivery system statements. So lastly, we're going to look at exporting data. We're going to create a simple raw data file using the export procedure I did touch on in the first video in this series when we were using the import procedure. And lastly, we'll look at exporting data to Microsoft Excel using SAS Access XLS engine. So that'll be using a live name, similar to how we imported data from an Excel file in the first video in the series. So let's jump into the code and look at these by example. So yeah, we're just going to jump right into creating HTML, PDF, RTF files with ODS statements. So they're all very similar. So HTML file, and I'm going to put all these in my local working directory because they'll be fully reproducible whether you're using a Mac or a PC. So again, I could, depending on whether you're Windows or Linux, put this somewhere else. I'm just going to put it right in my working directory. And I'm just going to use the print procedure to make these files. And since I have a working I have a work library data set called cars that I made in a previous section of this video. So I'm just going to use that. So you run procedures within the ODS HTML statements, and so between ODS HTML file equals and ODS HTML close, you could put several different SAS procedures. Like, I'm just doing one Proc Print. So this is just for a basic example. Oh, and so, yeah, I can't actually write to my working directory. So, forgot that. So I'm actually gonna write to so following the installation for SAS Studio, that you will on a Mac create a folder called My Folders. I'm going to write to that. And that should work. Okay, so I'm going to leave it on. When I save this in the video, I'm going to comment out this and leave this in, because this will work for someone typically on a Windows computer, or they can or they can open it or they can open it in whatever way they want. So I did make the HTML file there. And basically, I'm going to put the examples in here for PDF and RTF, but they're basically exactly the same. I won't go through opening them all. As long as I don't have any errors and I see the files being created, I know that's going to be fine. And so, it's going to be exactly the same thing. RTF is a rich text format, so it's kind of like something you might open in Microsoft Word or Google Docs. And I think let's just make sure I don't have any syntax errors. And yep, looks like we're good. Logs there, files have been created. So yeah, I'm just going to leave it at that. You can look at these outputs and figure out your output destination yourself. Generally, if you have if you can write to your current directory, it would be easy to do that, because you may not have this path may not exist on depending on the way you set up SAS Studio when you installed it. So, but I will leave this in here, so you have that option. So that's about it really for the for those examples. Also going to mention the style equals option. So for style equals, there's a lot of different options you can add in there. One I know of is Proc Print. I'm going to call this a different name, BP. So this will output it in a different format to the default. And yeah, so oh, I spelled that wrong. So, and I think, did it tell me something in the log? Yeah, it told me style block print cannot be found. So let's run that again. We'll overwrite the existing one. So no issues in the log this time. And yeah, I'll just leave those outputs for you to look at. Now, creating files that can be used in Microsoft SL. Well, in SAS 9.4, it's very easy. You just use exactly the same ODS Excel statement as you did for ODS RTF. Just, make sure it's an .xlsx file. You can't do this with the old school version, the .xls file. So again, it's basically the same. We have an Excel file created. No errors in the log. And that's about it, really. It's a very brief overview in this exam of what you can do with ODS. So I don't want to go too in depth with it and get into unnecessary details. Again, this path may not work for you depending on how you set up SAS Studio. So based on your knowledge of the log from previous video, you should be tipped off to that straight away. So put in a valid path, or a path to which you have permissions to write. So next off, we're going to be talking about exporting data. So create a simple raw data file by using the export procedure. So for proc export, so we can make a raw data file of a different format. I'm just going to make a .csv file, and I'll express what I'm going to be making in the DBMS option. But I'm gonna, and that has to also be consistent with what I make the out file. So I'm gonna say .csv, cars.csv, and then DBMS equals CSV, and I know what I've done wrong. I shouldn't have a semicolon there. So these are all options. Replace. So I overwrite whatever's already there. I'm also going to put names equals yes. So that means the first row will have the column names of the cars data set. And a run statement. And again, I'm going to have to make sure this path exists. So I'll do this. So, and I'll put a note in the description below this. All this code will be posted. I'll put a note in there about the. I'll put notes in this program about the path for all of these paths, because they may not exist in your SAS Studio. So yeah, that's exactly what I wanted. 428 records have been written to this CSV file that I now have in here somewhere. Yeah, cars.csv, that's the one. Alright. And finally, I'm going to look at exporting data to Microsoft Excel using the SAS XLSX engine. So we covered this in the first video in this series, but we were importing data from Excel. So we're going to use a live name statement, and I'm going to call it XLSX out. It's the live ref, and you have to use this XLSX option, and then again valid path is necessary. And so when you make this Excel file, it doesn't have to exist. It can, or it doesn't have to exist. So right now there is no file called new cars.xlsx in this location. And I just write it out using the libref. And I'm just simply using a data step, and there you go. Now I should, in this folder, get a Excel file created called new_cars.xlsx. So I do, yeah, so that's exactly what I wanted. So yeah, and that's the last section in the last video. So again, I'll post some comments in this code. It's going to be saved on my GitHub page and linked in the description to this video below. So thanks very much. Of the SAS 9.4 base programming performance-based exam. This was the last video. We went through every section outlined in the white paper provided by SAS for the SAS 9.4 base programming performance-based exam. And again, all the code used in all of these videos is available in the description of this video below. And thanks for watching. And I plan to make a follow-up video on the SAS 9.4 advanced programming performance-based exam, which will be coming soon. Thank you.